All right, today we are going to look at factoring trinomials again, but a greater than 1. Now remember, a quadratic is ax squared plus bx plus c. The reason we know it's a quadratic is because the highest power in the expression is a 2, which means squared. If there's any value that is higher for the exponent, then it is not a quadratic. And in this case, we're going to be looking at the coefficient in front of the x squared. And if it's greater than 1, that's where we're going to use the diamonds and reduce this time rather than just using the diamond to get the factors, okay? The same rules apply. We're going to factor GCFs. We're always going to look to see if A is equal to 1 or if it's greater than 1. And if it's greater than 1, we're going to do more than just getting the diamond and writing factors. We're going to get the diamond, write the factors, and we're going to reduce. And I'm going to show you how to do that. And as always, you always FOIL to check your answer. You should get back the original problem. All right, next, we're going to keep our rules up, okay? And we're going to work off of this first problem. We have 2v squared plus 11v plus 5. Now you can see right here, our 2 is the coefficient of v squared, so it is greater than 1, okay? Now, we're looking for GCFs first, 2, 11, and 5. There's absolutely no greatest common factor. Since the 2a is greater than 1, then what we're going to do is as we have before, so the rules don't change. We're going to take the 2, we're going to times it by the 5. So the first and last numbers, the coefficient of the first and the last number here on the standalone number, go into our diamond and they get multiplied. So 2 times the positive 5 is 10. Our middle term is always added to get when we do distributing properties. So we're going to take our middle term of 11 and put it here. Remember, absolutely no variables go with that, just the numbers. Right now we're going to use our smarts and we'll come up factors of 10 that could add to 11. Well, factors of 10 are 2 and 5 and 1 and 10. Well, 2 and 5 are going to either give us 3 or 7, so that's out. And this will give us either 9 or 11, so that's in because we need 11. So we're going to write 10 and 1. They're both positive because we want to multiply to positive 10 and add to positive 11. Okay, so now, just as you did when we were factoring when a was 1, you're going to open up your parentheses, and you're going to take this first term, the entire thing, 2v and 2v, goes here, and it goes here. You're going to take your diamonds, and as we did before, we're going to add 10, add 1. But now the bigger thing is we have to reduce. So we look at each of the factors and we can see we can reduce 2v and plus 10. So this is going to reduce by dividing by 2. Okay, so we're going to divide by 2, divide by 2. And we're going to get v plus 5. 2v plus 1 can't be reduced. And I'm just writing these notes for you. You're not going to do this every time. You're going to think it, do it, but you're not going to write all this. So 2v plus 1 comes down. Then your final answer is the quantity of v plus 5 times the quantity of 2v plus 1. Now here I'm going to do a quick check with you so you can see how this works. And how do you know that you're correct? V times 2v is 2v squared. This is my check. It's bad too. Okay, so that's v times 2v. V times 1 is 1v. 5 times 2v is 10v. And 5 times 1 is 5. So we get 2v squared plus 11v plus 5, which is what we had in the beginning. So it checks. So our final answer is boxed. Okay, it's the quantity of v plus 5 times the quantity of 2v plus 1. All right, next problem. We're going to give a shot here. We look for GCFs, 2, 3, and 9. No GCFs. Next, we're going to see if the a value is 1 or if it's greater than 1. So look in front of the squared term. And the value is 2, so we're going to do the diamond and write the factors and reduce accordingly. All right, so here comes our diamond off to the side. We take the first number and the last number with the signs. 2 times -9 is -18. We take our middle term and put it on the bottom. And we're looking for factors of 18 that could add to 3. So make a list. 18, start with 1. 1 and 18, 2 and 9, 3 and 6. So 18 and 1 will give me 19 or 17, so he's out. 2 and 9 can give me 11 or 7, that's out. 3 and 6 can give me 9 or 3, so that's in. So we're going to do 3 and 6, and it doesn't matter which side to put it on. We need it to multiply to a negative, but add to a positive. So we need more positives than negatives, so the negative goes on the 3. Check it out. 6 times -3, -18. 6 plus a -3 is +3. Okay? Now, factors. Just like we did before, we open up 2 parens. Whoops. Our first term, 2n, comes into the first term of each of the binomials. Our completed diamond, +6 and -3, go into our factors. Now we have to look through each one of these and reduce accordingly. If you did not take out a GCF and you reduce, you're going to lose it. That's why you always check the GCF first. We checked the GCF, we didn't have one. But now we're going to reduce, and this guy reduces by 2. So we'll divide by 2, divide by 2. And we're going to wind up with n plus 3 times 2n minus 3 does not reduce, so we keep 2n minus 3. And you should check, so I'm going to do this quickly. 2n squared, bingo. 6n minus 3n is +3n, and -9, done. So that is our final factorization of 2n squared plus 3n minus 9. All right, let's take another look at another one. Okay. So remember, signs can be different on a lot of these. All right, first thing we're looking for, factors of GCF. Nope. It is a trinomial, 3 terms. A is greater than 1, so take our diamond. 3 times -5, -15. -2 on the bottom. Factors of 15, that could add up to 2. You list them, we wind up with 5 and 3. We need it to add to a -2, so -5 plus 3 is -2, and they multiply to a -15. All right, now we build our factors. 3p comes from the first term, -5 plus 3. Reduce accordingly, and this one is the one that can be reduced. So 3p minus 5 cannot be reduced, so it comes down. This can be divided by 3 on each, giving us p plus 1. So our answer is 3p minus 5 times the quantity of p plus 1. And that's our factorization. And again, quick check. 3p squared minus 5p plus 3p is -2p and minus 5. All right, let's check another one. Okay. 15n squared minus 27n minus 6. Now, as the numbers get larger, more than likely you're going to have a GCF, so check it out. 15, 27, and 6. They're all divisible by 3. That's the largest number. So you're going to take out your GCF. Okay, so GCF here. All right, now, when we do that, we're going to get 5n squared minus 9n minus 2. So this is still the same equivalent to this, but it just looks different by factoring out the 3. Now, remember, when you do your diamond, you're only doing your diamond based on the trinomial. This guy, this top guy, if the original problem is done, you're focusing only on this one now. So our diamond comes here. It's 5 times -2, so it's this and this, which is -10. -9 goes in the bottom. We need factors of 10 that could possibly give us a 9. So 10 and 1 would work. They got to be -9 when we add, so -10 would do that. And -10 times 1 gives us a -10. Okay, now, when we do our factorization, Remember, we have to keep our GCF of 3, so he has to just come down for the ride. Open up 2 parentheses, 5n, 5n, minus 10 from our diamond, plus 1 from our diamond, and reduce accordingly. As you can see here, this can reduce. So we're going to get 3, because that comes down. It's part of our factors. It's a greatest common factor. This can reduce by 5 and 5. So this is going to give us n minus 2. And the 5n plus 1 can't reduce. And you're there. Okay, now, quick check. We start with the binomials. 5n times n, 5n squared. Negative 10 plus 1n, negative 9n. Minus 2, so negative 2 minus 2. Then we're here, because we still have our 3. 15, 27, 6, and we're back to the top. So this is our final answer, and we know that we have it correct because we did a quick check, and we're done. Okay? All right, one more. Let's take a look at. All right, if you have a greatest common factor, you take it out. So negative 6, negative 25, negative 25. I don't have any. Okay, so it's pretty big. All right, so we don't have one to take out, but we do have a negative on the first term. Always factor out the negative on the first term. So what we're going to be taking out is a negative 1, because we don't have any other numbers that can divide into all these, but the first term can never be negative. All right, so take a note. First term can't be negative. So in this case, our GCF is a negative 1. So that'll change this to positive 6a squared plus 25a plus 25. All right, now you got to play around here with calculators, okay? So have your calculator out, handy dandy. Diamond, 6 times 25. Okay, you ready? 6 times 25 is going to give us 150. 25 goes in the bottom. Whoops. We need factors of 150 that will add to 25. Now, before we start with 1 times 150 and 2 times 75, etc., let's think more logically. Anything that ends in 0 is a multiple of 10. 10 times 15 gives us 150. And lo and behold, since they're all positive numbers, 10 and 15 will add to 25. So just a little trick. Bring your GCF down. Open up with 6a and 6a coming from our first terms. Put your diamonds in so they're both positive, so plus plus. And now what you can see here, even though we did not have a GCF, so we're not losing anything, we have 2 things that can be reduced by different values. 6 and 10 are reducible by 2. So we're going to get negative 1. We've got to keep our GCF. This is going to be 3a plus 5. And this 6 and 15, again, this one's reducible by 3. So this is going to give us 2a plus 5. All right, so it's kind of funky, but that's our final answer. And to check it really quick, leave the GCF alone. Positive 6a squared, right here. Positive 10a plus 15a is 25a. 5 and 5 is 25. So now we're back here. Put your negative 1 in, you're going to get a negative 6, negative 25, negative 25, and that's our original. So you know that the factors you got are 100% correct. And that's how you factor trinomials that have a value of a greater than 1. And in this case, where it's not greater than 1, it's a negative 6, you take that negative out and we turn it into a trinomial of a greater than 1, because you have to take out a GCF. First terms can never be negative.